Hi everyone, my name is Flax. I'm a backend engineer and open source entrepreneur. I'm the developer of the extra Ktor plugins library, which is a library that was created to kind of like enhance Ktor capabilities. I created it like almost 2 years ago. Later it was the first plugins to be registered in the plugin registry. Were those. In this talk, we're going to talk about using Ktor for server-side development. We're going to discuss what are the advantages and disadvantages of adopting it. We're going to show how we can achieve with it the same capabilities that we expect from a backend server framework. We're then going to set up an example system utilizing existing plugins for backend development. And we will learn how we can easily do it ourselves, and that we should, probably. So let me start by asking, who in this room is using Ktor? Okay, I see about 50%. That's good. Is it mostly for client hands? Minority? Okay, good. And server majority. Nice. Cool. Anyone has been developing plugins? No, but 1, 2, 3, 4, 5, something like this. Okay. But anyone has been using plugins that are available already in the registry? Okay. So I take it that there's kind of a majority of the Ktor server users that are not using plugins somehow, yeah? Or maybe everyone that's using Ktor server is not using plugins can raise their hand. Okay, so the math doesn't make sense. So I would assume that most of the Ktor server developers are using plugins but not developing them. So maybe we can talk about why do we want to use Ktor at all? So as we know, when we consider using Ktor as opposed to a more established framework such as Spring Boot, then what are we actually getting? So as we say, it's lightweight and minimalistic. You don't pull in as many dependencies and capabilities that might come with another framework, like with Spring, for example, the dependency injection comes built in, but here we're just dealing with the server. So you only pull in the components that you need. So this is usually very good for smaller deployments, and I think it leans toward microservices as well. So also we have the concept of explicit and clear configuration. That's kind of part of Ktor's philosophy is the opposite of convention over configuration, where you don't have any magic happening out of the box. It's anti-magic. So every capability that you want to have, you explicitly define. It's natively running in the Kotlin context. This is something that, with the Spring Boot, as far as I know, at this moment is still not the case. It is true for reactive Spring, but not for Spring Boot Web, as far as I know. Whereas with Ktor, you're always running in the Kotlin context. What else? Fully Kotlin-centric, idiomatic. You're distancing yourself from all the Java stuff, when you work with a framework like Spring. There's a lot of points of contention where the things don't exactly line up, and there's hacks to work around that. Starts quickly, I would say. Quicker to iterate over. Low resource consumption as well, I would say, relating to that. What else? Yeah, so I was mentioning before Ktor's values. So I think it was said best last year by Garth. So he was saying exactly that. It's the antithesis of convention over configuration. It never does more than you ask it to. Placing a jar on the class path doesn't cause anything to happen. It's only giving you the capability to make something happen. So we're going to see how these values then relate to what we do when we develop with Ktor. So the current state of affairs, when we're talking about the adoption of Ktor, as we were doing this mini survey here, as from what I can tell, we have about 80% of Kotlin backend developers using Spring Boot, whereas about 9% are using Ktor's server. Sorry. Yeah, I did a rough count of the number of Spring starters that are available just by counting in the IntelliJ project wizard. We have 138. For Ktor, we have 67, but I'm pretty sure that digging deeper into those numbers would show that there's actually a lot more in Spring and probably 67 plugins in Ktor. But yeah, I think the breadth of capabilities that you have is much lower, but mainly it's the maturity. Sorry. So with Spring, these have been used for years, decades, almost, I would say. Whereas with Ktor, we're talking about up to 4 years max. Sorry. Yeah. Okay. So given all of that, let's talk about how we actually can maybe change those statistics and start to see how we can move towards developing backends with Ktor server. So let's imagine we have our little system here. Sorry. So we have a system. We have an event producer that produces events on some frequency. It publishes those events to Kafka, and then we have an event consumer that would consume those events, store them in memory, and then we would have a client that would request those events from a REST endpoint. Okay? Yeah, that makes sense. Cool. So before we're talking about any plugin development, plugin usage, writing any plugins, let's just see how we would just set up a minimal server that would produce events. So we define our main function with a server, port, IP, and a module, okay? And then we would have our module. And then we would define a function for sending events that it will take the ID from the environment config. Am I hearing feedback? No. It would create an event using that information. And for now, we were just going to log it because we're not dealing with the infrastructure right now. So we would want to then create a job that would just repeatedly, at a certain frequency, send those events. Okay, a frequency of 1 second, let's say. And then we would just define a function, which is an extension function of the application, that would produce the events, which is just upon startup of the application. So we monitor, we subscribe to the application started event, and we would just log and launch that job. So what we would have here is basically the application starts. Upon its start, we launch that job, and as long as the application is active, we are sending events, or rather logging that we are sending events in a frequency of 1 second. So, yeah. So we register that function in our module. As we can see, the application module now calls this function. So we're good to go, right? It's going to work. But what are the problems that we have here? So, I mean, we we have high coupling here, right? We subscribe directly to the events using the monitor objects. The event handling logic is tightly coupled to the application setup. So it's not really reusable as much. And if we're talking about like once we get into more complicated configurations, then like we're kind of limited here. Like it works for this case, it's fine. But it's not scalable, it's not modular, and it's highly coupled. Yeah. So let's talk about how we can do the same, but with the Ktor application plugin. So this is the Ktor plugin API. Basically, there's an interface. By the way, this is just relevant for the Ktor server plugins. The Ktor client plugins have a different interface. So we have a plugin interface, and it has a key, and it has an install method, and then it has two branches of implementations. Before Ktor version 2, you had this base application plugin. I mean, you still have it, but now there's the application plugin, which implements it and hides away the complexity of dealing with the pipelines. So it's basically since Ktor 2, the API for creating plugins was simplified, and now we're just dealing with the application plugin and root scoped plugin. The difference between the two is the type of pipeline that they're dealing with. So what we are really concerned with is just a configuration, which is anything. Any class can be a configuration. Okay. So now let's talk about creating a plugin. So Ktor gives us functions for creating plugins. Either application plugins or root scoped plugins. Oops. In this case, we want to create an application plugin because we're not dealing with any routing. So let's define a function for creating an application plugin. Well, this is not us defining, sorry. This is the actual function from the plugin API. So this is the application plugin creation function, which accepts a name and a body, which is just do something with the plugin builder. You create a plugin with a name, and then you do whatever you want with it. Let's see how we do that. So, yeah. So let's define a value, which is a produce events plugin. We're going to call the create application plugin using that name, and then inside the block we have access to various components of the plugin builder. In this case, we want to monitor the event as we did before, and upon this event, we would log and launch the event job. Okay. So we kind of like did the same as we did before. Sorry. Yeah. And then we would want to install this plugin. So shouldn't be like this, but yes. And then in the produce events function that we had before, we just install this plugin, and that's it. So then our application looks like this. Not much of a difference. It achieves the same, does the same, but yay, we use a plugin. So again, like we didn't really achieve much here, but what's a potential issue here? So we are hard-coding the frequency. So we can probably do better than that. It's not really best practice. So let's do a plugin configuration. This is the function for creating an application plugin with a configuration. So as before, it accepts a name, but this time it also accepts a block that would return your plugin configuration, which again is anything, and a body for working with the plugin builder. So now we're going to create our configuration. So we define this produce events config. Now, it's best practice to use vars here for the configuration classes, and depending on the use cases, also provide default values, as this would have an effect on how installing them looks like. But this is part of the kind of style that you would see a lot when you work with developing plugins is that you basically have a block, a lambda, that you operate on an object that has vars, and that affects, that is taking into the processing of the function and would have effects. So we define our configuration, and now, as before, we create our produce events plugin. We call this function create application plugin, produce events, and now we pass to it a function, which is just a reference to the constructor of our configuration. And then, as before, we do what we did before. But this time, okay, so this is actually a mistake of mine here, but we should have passed the duration into the launch events job. But the principle, I think, is understood here. So here we would do produce events. Like now we're installing the plugin, installing a configurable plugin. So we, as before, we do install produce events plugin, but we pass to it a block, which we say the frequency in which we emit the events would be 1 second. Again, it should have come from the configuration, my bad, but I think you understand the idea. Okay. Yeah, and it would be even better if instead of, because what we did before, we were still hard-coding it. So what we can do here is actually take that property, which would be defined in our application configuration somewhere. And this could be made a lot less verbose. But again, so this is what it looks like at the end when we are installing our configurable plugin into a server that we just created. So again, we didn't achieve much here. Like, to be honest, everything that we did, we could have done with the more imperative approach that we did before. But all of this becomes a lot more important when we consider scale, encapsulation, intent communication, and other concepts. So let's see how we can use plugins to further support our system that probably would need more capabilities than this. So, going back to our system, sorry, as of now we're not doing anything with when we set events, we just log them. So, as stated in our system diagram, we want to actually publish our events to Kafka. So let's use a nifty little plugin that I created that helps us in doing that. So we create a function for configuring Kafka that installs the plugin. Like now we're not creating the plugin because this plugin I've created and it's highly complex. But what is not very complex and is quite nice to look at, I think, is how we actually install, configure it, and use it. So we create this function, it installs a plugin and configures it, and we configure it according to our needs. We define a topic here, we define the schema registry URL. The topic is defined here, configured here rather. We define our producer, the bootstrap servers, retries client ID, and we register our schema like that. So all of this is kind of like what I was talking about before, which is the pattern that you would see a lot when you work with plugin configuration and modifying them, is that you have a lot of lambdas, you operate on the configuration, you modify values. Okay, so this is how we configure Kafka. So now let's talk about consuming events. So we publish the events to Kafka, but we also have our consumer application. So in it, we create a function to store the events. So basically, we take an event, and we log that we got the event, and we store it in our event store, which we don't worry about. And then we have a function for configuring Kafka for the consumer. So again, here we install Kafka. We define the same topic name, schema registry URL. We configure our consumer. And here, we define a record handler for that topic that in the block that it accepts, we have access to the record, which we then parse the event from. And this is using Avro4K in the background. All of this is done by the plugin and abstracted away. And then we call our onEvent function. OK, so now we have a consumer and the producer that communicate events between them using Kafka. But again, if you look back in our system diagram, we saw that we're going to have multiple producers. So the next question is, like, how do we actually coordinate between them? Because we don't, in most cases, we don't really want to have the same event emitted by multiple producers. We want to have some scheduling and coordination between them. So how do we do that? Task scheduling and coordination. In our producer application, we have this function. We'll create a function, application configure tasks. We install the task scheduling plugin. We define a name for our manager, which we are going to use Redis, as you will see in a moment. So here this is how we say, I want to use Redis as my lock manager. We use the name, we define host, port, username, password, etc. And then we define a task. And we say that the task is going to be using that lock manager. We could have more lock managers using different data stores like JDBC or MongoDB. In this case, we're going to use Redis, but we can have different tasks working with different task managers. So we define the name of the task and the task itself, which is just sending the event. And we give it a schedule. Here we're using the cron DSL, which is a lovely library, which is doing basically cron in a very Kotlin style, like this. And that's it. So now we've configured task scheduling. So again, like, we replaced what we did before with this explicit launch every 1 second. Now we have a declarative approach where we define a task that needs to happen with a cron schedule and is managed by some lock manager, which in this case is implemented in Redis. So now that we have the multiple producers coordinating the tasks between them, and a consumer that saves the events. So this is what it looks like. I'm sorry about the Yeah, so now we have, we also have the client that is communicating with the consumer. And, sorry, this is the consumer, which has a route that exposes getting those events. So the question is here, how do we handle load on our consumer? So if we have like billions and gazillions of clients trying to fetch the data from the consumer, how do we make sure that we don't that it doesn't go boom, basically? So for this, we can use rate limiting, which is another plugin from said library. So we'll define an extension function on route. So what's different here is before we were dealing with the application scope plugin. Now we're going to be dealing with a route scoped plugin. So this is something that operates on the call pipeline, which is it's going to be specific to a route and is not going to operate in the scope of the whole application. So we define an extension function on the route. We install the rate limiting plugin, which is a route scope plugin, onto that route. And then we define a rate limiter. The plugin offers us different types of algorithms to be used. We're going to go with a token bucket here. We define a capacity and a rate. And we're done with that. And then we're going to create an extension function for application to configure, well, this is the configure routing function for the application, in which we have defined before the route to get the events. And now onto that route, we configure rate limiting. So again, like before we were doing stuff on the application level, now we're doing stuff on the route level. So we configure rate limiting for that route, and that would do it. So now, the last piece of our system is the client that fetches the stored events. Here we have it as part of a main function, where it makes a GET request every second. In this case, we know that we're going to either get rate limited, or maybe we encounter any other issues, as the server may be down, or who knows what might happen. So we want to make the client resilient to any such issues, and for that, we'll be using the circuit breaker pattern. So let's see how we configure circuit breaking for our client. Extension function for our client config, setup circuit breaking. Here we install the circuit breaking plugin. We define a global behavior as such. And the nifty thing is that we can also define a more strict policy, let's say, or a more permissive policy, or whatever policy. But the point is that we can have a global policy and specific policies, and apply those either by default. Every request is using the global functionality, whereas the global strategy, rather. Whereas we can then explicitly say, but I want this request to be using a more strict policy. So here, register a strict policy. And nothing is moving now. Yeah. With a more strict behavior. So we say our half-open failure threshold is 1, reset interval is 5 seconds, whatever. It's just a different configuration. Okay? And now, let's see how our resilient client looks. So again, like before, we created the scope and the client. So now, in the configuration block of the client, we call our function, setup circuit breaking. And as before, we do all this, but now the difference is we have here client request with circuit breaker, and we pass to it the strict policy. And here we get the events from the consumer, we log them, and handle the failures. Okay, so, I mean, it would have been better to see side by side, but basically the difference is that we added this setup circuit breaking here, and we added the request with circuit breaker. It could also be request with circuit breaker without the strict argument there, and then it would just use the global behavior. Yeah. So now we can see our system in action, and for this, I'm actually going to. Well, I took some like snapshots of the logs here, but it would be more interesting to actually see all of that happening live. So I'm just going to move over here and do this. Yeah. Okay, so now we're going to launch on system. And we're going to see here. This is harder than I imagined, but yeah. Yeah, so this is our first producer. Yeah, it's actually starting now. Dum, 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 dum. So producer 2 is responding here. Producer 1 here, sending events. Producer 2, we will see that it's going to be sending events soon. It's just that producer 1 is, yeah, here we go. This one is also sending events. Now, this is our consumer receiving events, and saying hello from producer 1, hello from producer 2. And our client, we will see that initially we were having successful responses, and then it's been getting into the circuit breaking because we were getting failures and due to the rate limiting. and then again, the circuit breaker closed again, and we get responses, and then again, circuit breaker kicking in. Yeah. So this is our simple system using 4 different servers, communicating with each other using Kafka, with rate limiting and some resilience. I think that is all.